Sketch the function f of x is equal to -1 divided by x squared plus 1 plus 4. For a rational function, what we need to find is the vertical asymptote and the horizontal asymptote. Horizontal asymptote is given in terms of y values, the y value that the function will be able to touch. Now, when you look at this, the highest power on top compared to the highest power down, the highest power of x down is bigger. And as long as the highest power of x down is bigger than on top, horizontal asymptote will always be at 0. Now, to find the vertical asymptote, you equate the denominator to 0. If you equate the denominator to 0, you're going to find that x squared plus 1 is equal to 0, x squared is equal to -1, and you'll not be able to find the value of x. It will give you the square root of -1, and that is I. It is not a real number, meaning that we don't have any vertical asymptotes. Then we can go on and see how the function is going to look like. If we look at this function, we have got a constant 4 which has been added to the function. That 4 shifts the graph in the y direction. So if it was a -4, it would have shifted this graph to the negative values. If it is positive, it shifts the graph to the positive values. So this is going to be the shift. Okay, that is the shift there. So then now are we going to be able to sketch this function? Meaning that the horizontal asymptote was supposed to be at 0. But because there is this shift, the horizontal asymptote is now at 4, at positive 4. So then what is going to happen? If we look at the denominator here, if I want to have the smallest value of the denominator, x should be 0. If I go to the negative or the positive, the denominator is going to increase. Let's say x is 0. What will be the y value in the denominator? It will be 1, because 0 plus 1 is 1. If I say x is 1, 1 squared plus 1 is going to give me 2. If I say x is -1, it will still give me 2. If I go to 2, 2 squared plus 1 is a 5. If I go to -2 squared plus 1 is still a 5. As long as x is not 0 in the denominator, the function will go on increasing in the denominator. So what does that mean? When the denominator is increasing, it means that the function is reducing. Okay, so let's say when x is equal to 0, we are going to have -1 over 0 plus 1, which is just 1. So we are going to have -1 over 1, which is -1. And remember, this is plus 4. So that will be -1 plus 4. That is going to give us a 3. So when x is equal to 0, y is going to be 3. This is going to be the value. Now remember, the asymptote is at 4. So what is going to be happening as I go towards the positive values of x, the function is going to be changing. Now in this case, let's say this is going to be a 1. 1 squared plus 1 is 2. We are going to have -1 over 2 plus 4. -1 over 2 plus 4 is a 3.5. So the function is going to be going towards the asymptote in this case. Okay, so the function is going to be going like this. We will not touch the asymptote. And then also in this direction, it will be going like that. We will not be able to touch the asymptote. So then the domain of this function is from -infinity to +infinity. Those are the values of x for which the function is valid. And then the range of this function, the smallest value we can have is 3, the biggest we can have is 4. But we are touching 3, we are not touching 4, right? So if this function was positive here, the meaning of positive is it would have had a maximum. So if that was a positive, it means that this function would have had the maximum at 5, and then going closer to the asymptote, and then coming also down like that if it was positive. Why? Because still we'll put 0 here, it would have been 1 over 1 plus 4. That would have given us a 5. So that is how we get to sketch this function.